Okay, today we are going to look at the paper 2 section A. Okay, question number 1, table shows the number of protons, okay, and the number of neutrons for the atoms of R, S and T. So given to you, there are 3 atoms here, proton numbers and then neutrons. Okay, now the question asks, state 3 subatomic particles in an atom. So here, if the question asks you the subatomic, okay, so the answer should be inside the atom. So they are in the nucleus we have protons, we have neutrons, and then another one in the shells will be electrons. Okay, so 1 mark. Now, what is meant by isotope? Okay, so here, if you are asked to define the isotopes, remember, okay, there are a few things that you need to remember. Okay, so first one, they are atoms of same elements. Okay, so they are atoms from the same elements, okay, that have same proton numbers, okay, but different, okay, nucleon number. Okay, here you also can replace with same number of protons but different number of neutrons, also accepted. Okay, so here you remember you have to mention this one also, atoms of same elements, okay, they have same proton number but different nucleon number or different number of neutrons. Okay, now which atoms are isotopes? So we can see they have same protons, okay, same protons, meaning that here 11 protons same, right? But different neutrons, so here 12, here 13, so meaning that the atoms should be 2 here, R and S. So you should write R and S. Okay, now state the isotope that used to treat cancer diseases. Okay, so here cancer diseases, so actually not in this table, not in this table. So what we use to treat the cancer patient, there is the cobalt 60, right? Okay, cobalt 60. Okay, it will release the gamma ray to kill the cancer cell. Now write the electron arrangement of atom T. Okay, so here is the atom, not the ion. So atom T, it has 12 protons, right? 12 protons, meaning that 12 electrons. So electron arrangement should be 2, 8, 2. Okay. Now what is the valence electrons for atom R? So atom R, we can see atom R here is 11, right? 11 protons or 11 electrons. So electron arrangement should be 2, 8, 1, right? Okay, but here the question asks you the valence electrons. So valence electrons is the last electrons at the last shell, so it should be 1. Okay, 1. Question number 2. Table shows the elements found in the period 3 in the periodic table and their respective proton numbers. So proton number for sodium until argon given to you. Okay, define the period in the periodic table. So what is the meaning of period? Okay, so this is not a popular question. So a period actually refer to what? Refer to a horizontal, right? Horizontal row. Okay, horizontal row in the periodic table, right, of elements. Okay, So B1, okay, what will happen to the atomic size of the elements when across the period 3? Okay, from sodium to argon. Okay, so this one is a very popular question. So the atomic size, what happens to the atomic size? It will decreases, right? Decreases. Okay, why? Explain your answer. So remember, okay, in order to explain this atomic size, so first we have to mention what? Okay, number of protons increases from sodium to argon, right? Okay, so if number of protons increase, what will happen? Okay, so force of attraction, okay, between what? Okay, nucleus and valence electrons or electrons become stronger. Okay, so remember, whenever you want to talk about the force of attraction, we should use the word stronger or weaker. Don't use higher or lower. Okay, so if stronger, meaning that it will attract the electrons closer to the nucleus, so it will reduce the atomic size, reduce the atomic size of the elements or atoms sodium to argon. Okay, now name the elements that forms amphoteric. Okay, so amphoteric, you remember this one, amphoteric. So only one in the SPM level. Okay, that is the aluminium. Okay, the elements aluminium. So we don't write aluminium oxide, but this amphoteric oxide, it should be aluminium oxide. But here, the elements that forms the amphoteric oxide, they should be the aluminium. Okay, then you should name it. Don't use the formula. Okay, the atoms that of the elements sodium and chlorine can react to form a compound. So here we know that sodium is 281, chlorine is 287. Okay, matter, non-matter. So state the type of bonds. Okay, here the question asks you the bond. You don't write compound, so this should be ionic. Ionic bond, or you just write ionic enough. Okay. Now draw the electron arrangement for the compound form. Okay, so electron arrangement. Okay, so meaning that the sodium atoms, you release one electron. Okay, so it forms a positive ion. So meaning that sodium, okay, this is a nucleus. Okay, so 2, okay, 2, 8, to achieve octet electron arrangement. So the charge should be positive, positive 1. Okay, then the 1 electrons is received by the chlorine atoms to form the chloride, right? So chloride. So it forms 1, 2, okay, 2, 8, 8, right? 2, 3, 4, 5, 6, 7, 8. Okay, shell number 2. Then third shell. 1, 2, 3, 4, 5, 6, 7. Okay, so 1 electron is received from the sodium atom just now. Okay, so the charge is negative. Okay, so normally we will write the positive ion on the left side, and then negative ions on the right hand side. Okay, sodium chloride. So the charge must be labeled correctly. Okay. So 2 marks. Okay, question number 3. Diagram show a chemical formula for the substance contained in a detergent. So this one is the formula. Okay. So what is the meaning of chemical formula? Okay. So chemical formula. Okay. So this one also not that popular. It is a representation. Okay, representation of chemical substance. Okay, using what? Using like this, using alphabet. And alphabet to represent what? Represent the atoms. Okay, and there are some numbers, right? Okay, numbers. Okay, to represent the number of each type of atoms in the compound here. Okay. Now based on the diagram, write the empirical formula. So empirical formula is actually one answer only. It should very short one. Okay. So we need to simplify it. Okay. 10, 16, 4 and 2. So meaning that we can simplify it by divide by 2 lah. So it becomes C5 H8 O2 then N1. Okay, so this one is the empirical formula. Okay, now washing soda is a chemical compound that can be used to remove the stubborn stains. Okay, so it can be produced okay, when the sodium bicarbonate, sodium bicarbonate NaHCO3, when it is heated, sodium carbonate, carbon dioxide and water are formed. So meaning that how are we going to write the chemical equation? So sodium bicarbonate NaHCO3, so decompose, so meaning that when decompose sodium carbonate, so you forms Na2CO3, and then carbon dioxide CO2, water H2O. Okay, so it is balanced yet? Not yet. So Na2 here, so here no, times 2 here. Okay, hydrogen 2, oxygen, yeah. Okay, so it's balanced. It's balanced. Okay, now if 0.2 of mole of sodium bicarbonate is heated, what is the mass of the washing soda is produced? So washing soda, it should be sodium carbonate, right? Okay, so washing soda, so this one. Okay, now you can see given to you already 0.2 mole of sodium bicarbonate. Okay, so here remember you have to do the mole ratio. So from equation, 2 mole of sodium bicarbonate, right? Sodium bicarbonate. So you produce 1 mole of sodium carbonate. That is the washing soda. Let's say now if 0.2 only, 0.2 mole of sodium bicarbonate. Okay, so what is the mole? So 2 to 1 means half, right? So meaning that if you cannot directly see the answer, you can use the cross multiply. So you get 0.1 divided by 2 sodium carbonate. Okay. So here the mole is 0.1, not 0.2, because the mole ratio. So if here you can find the mass. So mole is 0.1 times the molar mass. So molar mass for the sodium carbonate, you can total up. Sodium 23, then carbon 12, hydrogen 1. Okay, oxygen is 16. So we total up the molar mass of the sodium carbonate is 106. 106. So you will get 10.6 gram. Okay, 10.6 gram. Okay, unit must be stated correctly. Okay, question number 4. Table shows the physical properties of substance of two elements of group 17 in the periodic table. So group 17, so chlorine and bromine. Bromine, the formula is wrong. Should be bromine. Okay, physical property, so gas, liquid, melting point, negative 101, this one negative 7. So explain how does the atom of group 17 form an ion that have stable electron arrangement. So it means that we must know that group 17, it has 7 valence electrons, right? So 7 valence electrons. How to achieve octet electron arrangement? Meaning that it needs to gain 1 electrons. Okay, you need to mention 1. Okay, so compare the boiling point of chlorine compared to bromine. So you can see directly here. So here first you need to mention melting point of chlorine, or you want to mention about the bromine also can. Let's say here we want to mention about the chlorine, so you can see melting point is lower than bromine. Okay, why? Okay, first you need to mention the molecular size, or size of chlorine molecules. Okay, here we have to mention about the molecules because we are talking about the chlorine molecules and bromine molecules. So size of chlorine molecules, or molecular size of chlorine, is smaller than bromine molecule. Okay, then what is the consequences? So less heat energy is needed to overcome the weak, we can mention directly van der Waals, or you can mention about the intermolecular force. Between chlorine molecules. Okay, because it is weaker. Okay, then if the molecular size for bromine is bigger, meaning that the van der Waals force or intermolecular force is stronger. Okay, so more heat energy is needed to overcome it. Okay. So this is how we answer the questions to get the 3 marks. Now, what is the position of fluorine is above the chlorine. So what is the physical state of fluorine in the room temperature? So here you can see bromine is lower, is liquid already. Then chlorine is gas. Then definitely if fluorine, it should be also in the gas form. Diagram 4 shows a colored glass window. Okay, if we see the color glass window, okay, so manganese is used to make the color glass window. So state the name of the group of manganese in the periodic table. So here, if we know that the elements that have colored, you form the colored compounds, right? So it is belongs to what? It belongs to transition metals, right? Transition metals. Okay. Beside forming the color compounds, state another special characteristics of the transition metals. Right? There are another 3, right? Beside forms a colored compound, you can mention it can act as catalyst. Okay, what else? Any one of these, okay, it has have more than one oxidation number, right? I hope you don't forget this, and then it can form complex ions. Okay, so any one of these answers can be accepted. The question number 5. There are 3 shows the 3 physical states of metals. So copper, water, and then helium gas. So state the type of particles in the copper block. Okay, so particles, you should know what is the requirement of the questions, right? So if it is the copper block, so it's a solid, right? Solid, okay, pure metals, right? So the particles, it should be atoms. Then in the water, so water is a H2O, right? So it's a molecule. Okay. Next, draw the arrangement of particles in the water. So water is a liquid form, right? Okay, so liquid form. So the atoms, it should be drawn properly, Okay, some of it still stick together. Okay, there are some spaces. Okay, the size of the atoms should be almost the same, try to avoid the overlapping like this. Avoid it. Okay. So this is the gas form. Gas form. Sorry, in liquid form. Now explain the movement of the particles and then force of attraction. Okay, in the water. So in the molecule form. Okay, so in the liquid form, sorry. So the particles can move randomly, right? Okay, randomly. Okay, then how about the attraction force? Okay, attraction force of attraction, attraction force between the particles, is stronger than gas but weaker than solid. Okay, so this is how we mention the attraction force. We compare with the gas and then the solid. Okay, so that you can score the 2 marks. Now, the balloon is filled with 1.2 cubic decimeter of helium. So calculate the number of helium atom in the balloon. Okay, so here, given to you, this is the volume, right? Volume of gas. Okay, volume of gas. So first, we should find the number of mole first, right? Number of mole of helium. So volume given to you 1.2 over the molar volume is 24. So you will get 0.05 mole. Okay. So once you have the mole already, so you can find the number of helium atom. So mole is 0.05 times the mole Avogadro constant Na, right? So 6.02 times 10 power 23. So you will get 3.01 times 10 power 22 atoms. Okay. Now question number 6. Okay, given to you pH value for solution acid A and B, which have the same concentration. Okay, this one almost the same with the essay questions later. Both acid are monoprotic acid, so remember that. So acid A pH value is 1, B is pH 4. So we know that this one lower pH, meaning that this one is a strong acid, no? Okay, this one is a weak acid. Okay, so suggest a name for the acid A and acid B. So acid A should be strong acid now. So it would be hydrochloric acid. Must be a name now. Or nitric acid, right? Nitric acid. Okay. I reject sulfuric acid. Why? Because sulfuric acid is a diprotic acid. The question asks about the monoprotic acid. So this is rejected. So B weak acid, remember one. So ethanoic acid. No? Okay. Now, explain why these two acid solutions they have different pH value. Okay. So here you just mention the definition. So acid A is a strong monoprotic acid, right? That ionize completely in water, okay, to produce high concentration of hydrogen ions. Okay. Then acid B. Acid B is a weak acid. Okay, that ionize. Okay, the keywords ionize partially. Okay, in water to produce low concentration of hydrogen ions. Okay. So the higher the concentration of hydrogen ions, the lower the pH value. Okay. So 0.1, then 0.2, then 0.3. Okay. So 3 marks. So remember, in the exam. So very simple calculation as explanation. And then very popular also. Okay, now calculate the concentration molarity of the acid A. So molarity. So we know that So pH value, pH equals to negative log concentration of hydrogen ions, right? Molarity. So if we want to mention the pH now is 1, right? Okay, it's 1. So negative log molarity, so meaning that if now I want to find the concentration or molarity, so be negative 1, so it be 0.1 mole per cubic decimeter. Okay, use your calculator. So 1 mark. Okay, now if 25 cubic centimeter of FCA completely neutralize the 50 cubic centimeter of sodium hydroxide solution, so write a balanced chemical equation. Okay, so here let's say you choose one hydrochloric acid react with sodium hydroxide, so you form the sodium chloride and water. Okay, so 1 mark. Sometimes this one will be given 2 marks now. Now diagram shows a student adding sulfuric acid with same concentration in acid A to the sodium hydroxide. So I need to add 12.5. Okay, so this one 12.50 cubic centimeter if using the sulfuric acid. Initially is 25 cubic centimeter of acid A. So does the student add the correct volume to the sulfuric acid? Give a reason. Okay, the answer is yes. Okay, why? Okay, why? Because sulfuric acid is diprotic acid, no? Okay, the concentration of hydrogen ions in sulfuric acid is twice the concentration of acid A. Okay, so this is how we answer the question. 7. Okay, industrial wastewater containing heavy metal cations that should be treated before being released to the river or drainage system. So a sample of industrial wastewater is taken and analyzed for the presence of heavy metal cations. So this one heavy metals. So diagram shows the flow chart. So for the test now. Okay. Now here. Okay. So the test 1, you add in the potassium iodide. So it forms the yellow precipitate Q. And then lead 2 ions is present. So this one actually we know that is a lead 2 iodide now, meaning that this one contains the lead 2 ions. And then with ammonia it forms the white precipitate. Excess ammonia, white precipitate dissolved in the ammonia. So R ion is present. Okay. So what is the meaning of cations? Okay. So very simple one answer actually is the positively charged ions only. Positively charged ions. Okay, cations. You have the T, right? T like positive. So positive ions. So name the yellow precipitate form. So give a name. So it be lead 2 iodide. Okay. Now what will happen if the precipitate is heated and cooled again? Here you have to be careful. The precipitate is heated and cooled again. So meaning that here the precipitate is under the liquid or solution form. So if you heat it, meaning that lead 2 iodide, what will happen? So the yellow precipitate, if you heat it, yellow precipitate will dissolve when heated. Okay, and then this, it will form again. Okay, reform now, form again when it is cool. Okay, when it is cool, meaning that the concept of this question is the lead-2 iodide is, it will dissolve in the hot solution or hot state, but it will it is become insoluble it is in the cool state. Cool state. Okay, so the ionic equation. Okay, so we know that it is a lead-2 iodide, right? So it will form the lead-2 ions and then iodide ions. Okay, it is, make sure that it is balanced out. Now if 0.002 mole of potassium iodide solution is added, okay, calculate the mass. So here be careful. So potassium iodide solution, so here the iodide solution here, so it be 2 moles, right? Okay, so from equation 2 mole of iodide produce 1 mole of lead-2 iodide. Okay, so if 0.0002 mole of potassium iodide, so you produce half lah, right? 0.0001 mole of lead-2 iodide. So meaning that the mass be 0.001, no? 01 times the molar mass, so 461. So it becomes 0.0461 gram. Okay, 1 mark. So a lot of students do not do the mole comparison here, so you cannot get the marks. Okay. Now based on the test 2, identify the R ions. So R ions should be zinc ions. Okay, zinc ions. So test 2. Okay, now the industrial wastewater may contain the copper-2 ions also. Describe briefly a chemical test to confirm the presence of copper-2 ions. Okay, so all these are heavy metals, right? Okay, so you can choose sodium hydroxide or you can choose ammonia. Let's say you choose sodium hydroxide solution. So 8 excess sodium hydroxide solution into the wastewater. Okay, the blue precipitate is formed. Okay, this is for the sodium hydroxide. If you don't want to use the sodium hydroxide, you can use the ammonia also. So if ammonia, 8 ammonia excess ammonia solution into the wastewater. Okay, dark blue solution is formed. Okay, okay, question number 8. Diagram shows the apparatus to determine the rate of reaction between the hydrochloric acid and zinc metal. Okay, so zinc and the hydrochloric acid. So what is the meaning of rate of reaction? Okay, so here you can mention the rate of reaction. Here you can mention the release or formation. Okay, release okay, release of volume of hydrogen gas per time. Okay, over the time. Okay, state 1 observation in this experiment. So zinc metal with acid you will see what? You will see the effervescence, right? Effervescence occur, or colorless bubble gas release. Okay, write a balanced chemical equation for this. So zinc react with hydrochloric acid, no? So it produces zinc chloride and hydrogen gas. So this one times 2. Okay. Next, if the experiment is repeated by sulfuric acid, okay, to replace with hydrochloric acid, predict the rate of reaction occur. So sulfuric acid is a diprotic acid. So what happens to the rate of reaction? You will increase. Okay, you will increase or higher. Okay. Now in a commodity cooking event, Chai has assigned to it a potato as one of the main ingredients in the food. So explain how he can cook the potatoes quickly and state the factor involved. So here you just remember you need to mention the factor. You need to apply one of the factor. Okay. For example, let's say you can choose to cut the potato size, right? To a smaller size. Okay, so factor you can use is the factor of size. Okay, so he can cut the potato into smaller size. Okay, to increase the rate of reaction. To increase the, we mentioned to increase the total surface area. We emphasize or we explain a bit if size, to increase the total surface area. Okay, so that more heat is absorbed, okay, by the potatoes, so it can cook faster. Okay, besides that, you can choose the pressure also. Okay, he can use the pressure cooker. Okay, so if higher pressure, the temperature will be higher, so it can cook faster also, but size will be easier. Okay. Okay, now we look into the section B. Okay, question number 9. Table shows the information for 3 sets of experiments to investigate the factor affecting the rate of reaction between the zinc and the sulfuric acid. So for this 3 sets of experiments, okay, first we look into the concentration of the acid, 0.2. This set 2 also 0.2, set 3 also 0.2. So meaning that the concentration are the same. Then acid or sulfuric acid. So okay, we look into the zinc size. So with zinc powder, this is zinc granules, this is zinc powder also. But in set 3 there is extra 1 copper 2 sulfate solution. Okay. Then we can see the time taken to collect 40 cubic centimeter of the hydrogen gas. So set 1 33, set 2 45, set 3 with 25. So we can see the highest rate of reaction will be set number 3. Okay, set number 1 will be second one. Then lowest rate of reaction will be set number 2. Okay. So diagram shows the energy profile diagrams for the reaction between the zinc and the sulfuric acid for the set 1 and set 2. Okay, so we can see there is energy profile diagrams for these 2 set of experiment. Okay, set 1 and set 3. So we can see here, actually, set 1 and set 3. Set 3, it has extra copper 2 sulfate solution. We know that this is the catalyst. Okay, so for catalyst, it will lowers the activation energy. Okay, so it will lower the activation energy. In other words, the lower one will be the set number 3. Okay, set 3. So this is set 3. So this is set 1. Okay, so this is a reactants, this is a products. Okay, now we look into the question. So draw the energy profile diagrams as diagram 9. Okay, then label curve for set 1 and set 3. Just now I showed to you already. Now show and label the activation energy. So where is the activation energy for set 1 and set 3? So set 1 you put EA, then set 3 you put EA prime, EA prime in your diagram. So 4 marks. Okay, so first you need to label set 1 and set 3 as just now. Okay, then the other one you need to label the activation energy. So remember that the activation energy, it starts from the reactants. Reactants. So these are the reactants. So this level, okay, to the peak of the curve here. So in order to draw the correct activation energy, so I will encourage you to draw like this. Okay, you extend it outside the curve here. So EA prime is the lower one. Okay, so remember the level here must be exactly touch the line. Okay, cannot be drawn somehow like this. Like this. So this is wrong. Okay, wrong. This one also. Okay, so EA is from the reactants to the peak. Okay, so this is the original. Okay, avoid draw the activation energy here because you are not able to show the EA and EA prime at the same level here. Okay, so I encourage you to extend it, draw like this. Okay, otherwise you would draw like this. It's very difficult. So this is the with activation energy. Okay, for example like this. So if you show it here, okay, so this is the EA, then your EA prime you cannot show it because you need to shift a bit here. EA prime, then like this, it will be not accurate already. Okay, so it must be exactly from the reactants to the peak of the curve here. So I will encourage you to draw like this. Okay, don't draw like this. Okay, so 4 marks. B, write a balanced chemical equation for the reaction. Okay, so for the reaction to be the sulfuric acid with the zinc carbonate, with the zinc. So zinc react with sulfuric acid, it produces salt, zinc sulfate, and hydrogen gas. So this one, okay, the equation. So on the same calculate the average rate of reaction for the set 1 and set 2. Okay, so this is for set 1 and set 2. So for set 1, okay, remember for the average rate, we need to calculate volume divide by the time. Don't reverse. Some student you calculate time over the volume. So volume is given in the table, 40, right? Okay, time taken 33. So use your calculator. So you get 1.21 cubic centimeter per second. Okay, unit must be stated correctly. Okay, now set 2, volume over the time. So volume 40, time is 45. Okay, seconds. So you get 0.89 cubic centimeter per second. Okay. Now on the z-axis, sketch a graph of volume against time for Z1 and Z2. Huh? So Z1 and Z2. Okay. So volume of gas. Okay, volume of gas unit must be stated correctly. Okay. Then time is seconds. Okay. Then we know that Z1 higher rate of reaction than Z2, right? Okay, so Z1 and Z2 must be labeled correctly. Okay, so it is a curve lah. Then their number of mole are the same, so the volume of gas collected will be the same. Okay, now C. Compare the rate of reaction between Z1 and Z2. The other one will be Z1 and Z3. Huh? Okay, now Z1 and Z2 using the collision theory. Huh? So we know that the Z1 and Z2 are using the different size, right? Okay, so Z1 and Z2. So the rate of reaction for Z1 is higher than Z2. So you must use the correct word. Z1 higher rate of reaction. Huh? Okay, the rate is higher. Don't write faster. Huh? Reject faster. Okay. Now, why? Size of the zinc used in the experiment 1 is smaller because it used the powder form, right? Then total surface area of the zinc atoms in the Z1 is bigger or larger. Okay, so remember the words total. Okay, so this is point number 3. So here reject higher, don't write higher total surface area. Okay, you must use the bigger or larger total surface area. Okay, point number 4. Frequency of collisions. Okay, frequency of collisions between the particles. So the particles here, you must know that it is between the zinc atoms because it's a metal, right? And then the hydrogen ions from the acid. Okay, so you must mention the atoms and then the ions, hydrogen ions. In a Z1 is higher than Z2. Then finally, point number 5, frequency of effective collisions. Okay, effective collisions between the zinc atoms and the hydrogen ions in Z1 is higher. Okay, so 5 marks. Each point 1 mark. So 5 marks for Z1 and Z2. Okay, huh? So remember, we will separate it like this, Z1 and Z2. So all the explanation is for the Z1 compared with Z2. Okay, then number 2, we will compare the Z1 and Z3. Okay, so we separate them, Z1 and Z3. So for these two set of experiment, for rate of reaction in the Z3 is higher than Z1. Okay, why? Because the presence of copper 2 sulfate solution as a catalyst. It is the catalyst. So you can mention the catalyst provides alternative pathway with lower activation energy. Okay, so it will lower the activation energy. Okay, so this is what the catalyst do. Then more colliding particles able to achieve the lower activation energy here, right? Because the activation energy is lower already. So more colliding particles. These particles, you can mention the specific one. Okay, if not mentioned here, you can mention the last point. So effective collisions, you have to mention effective collision. Okay, between the particles here will be the hydrogen ions with the zinc atoms is higher. Okay, so for Z1 or for Z3. Okay, so that's why it has a higher rate of reaction. Okay, question 10. Table shows the information for solution P and solution Q with same concentration, so you have to pay attention here, but different pH value. Okay, so solution P, the pH value less than 7. Okay, it react with copper 2 oxide to produce a copper 2 nitrate. Okay, so this is a salt, right? So nitrate salt, so meaning that the acid should be nitric acid, no? Okay, then Q, pH less than 7, so react with sodium hydroxide solution to produce the sodium ethanoate and water. So sodium ethanoate salt, so meaning that it has the ethanoic acid, no? Okay, so ethanoic acid would be CH3COOH. Okay. So based on the table, state the name of the solution P and solution Q. So you cannot use the name, you must use the you cannot use the formula, you must use the name. So P will be nitric acid, Q will be ethanoic acid. So which solution has a higher pH value? So we know that if lower than 7, higher pH will be less acidic, right? So here will be weak acid will be having the higher pH value, right? So Q has a higher pH value. Okay, why? Explain your answer. So it has a lower concentration of hydrogen ions because it is ionized partially in water to produce low concentration of hydrogen ions. Okay, B. So diagram shows the apparatus to use in the titration process of acid and alkali. So here using the sulfuric acid and then sodium hydroxide solution with the phenolphthalein. So state the type of reaction that occur in the reaction. So in this reaction, so it will be neutralization, right? Okay, neutralization. Okay. So first, the type of reaction will be neutralization occur. So chemical equation, so sulfuric acid react with potassium hydroxide. It will produce a salt and water. Salt will be potassium sulfate, water. Okay, you need to balance the equation. So 2 moles of potassium hydroxide, 2 moles of water. Then after that, you calculate the molarity of the sulfuric acid if endpoint of the titration is 10 cubic centimeter. So class here we can see the potassium hydroxide is a bit alkaline. So the volume is 20, so be VB. Concentration of the alkaline will be MB. Okay, for base now. And then for the volume of the acid will be 10. So this is this is for the VA. So you need to find what? You need to find the molarity for the sulfuric acid. So we MA. Okay, so we can use the formula MAVA equals to over MBVB equals to A over B. So MA and MB we are given already. So VA is given. VB also given. So MA is not given. So we need to find out the MA. So A over B, A is the mole for the acid here will be 1. Then B is for the base, will be alkaline, so it will be 2. So we replace in all the information here. So you need to find the MA. So like this, you can use the cross multiply, use your calculator, you calculate. So you will get the MA, it will be 0.5 mole per cubic decimeter. Okay. Okay, next question, C. Okay, table shows the apparatus for 2 sets of experiments to investigate the electrical conductivity and one of the acid property. when the hydrogen chloride dissolves in solvent X and solvent Y. Okay, so here for set 1, we test about the electrical conductivity. Okay, so you can see in the set 1, okay, so hydrochloric acid in the solvent X, it can conduct electricity. In other words, the acid must be in the solvent. X will be water, very simple, H2O, so that it can show the acidic properties. Okay, then for the solvent Y, you can see the bulb is not lights up. So in the solvent Y, this one should be any organic solvent. Okay, any. Okay, example like propanol. Okay. Then for set 2 would be the same concept. In the solvent X, you can see it produces the colorless bubble gas, right? Bubbles, right? When it react with the calcium carbonate, then it will turn the lime water cloudy. But for the in the solvent Y will be same in the organic solvent, so there is no bubbles produced. Then the lime water will remain constant, remain unchanged. So suggest solvent X and solvent Y. Just now we mentioned already. So solvent X. Okay, so explain the difference in the observation in the both set of experiments. So we focus on set 1 first. So first we need to mention about the solvent. Solvent X, so it's a water. Okay. Then solvent Y, organic solvent, like methylbenzene, propanol, or any suitable organic solvent. Okay. Now we need to explain the difference, right? In set 1, so we know that this one, the bulb is lights up, but for the in the solvent Y, the bulb is not lights up, right? So in set 1, the hydrochloric acid, HCl, in the solvent X in water, it will cause the bulb lights up, but bulb in the hydrogen chloride in the solvent Y does not lights up. Okay, so you need to explain why. Hydrogen chloride in solvent X, it can ionize to produce a freely moving ion. So what are the ions that can move freely? So there is the hydrogen ions and then the chloride ions. So they are move freely because in the water it can ionize. Okay, but in the solvent Y, it does not ionize. Not ionize. There are no freely moving ions, or they still exist as molecules. Okay, molecules of hydrogen chloride still in the molecule form. So there is no freely moving ions. So hydrogen chloride in solvent X can conduct electricity. So this one can conduct electricity, but in solvent Y cannot conduct electricity. Okay, so 4 marks. For set 2, explanation will be the same. Okay, so hydrogen chloride in the solvent X, that is the water, it will cause the produce of the gas bubbles or effervescence. Okay, but in the solvent Y, it does not produce any gas bubbles, or you can say no change. Okay, then you need to explain why. So hydrogen chloride in the solvent X, it can ionize to produce the hydrogen ions. Okay, then hydrogen chloride in solvent Y does not ionize, so there is no hydrogen ions, or it still exists as molecules. So hydrogen chloride in solvent X, it can show the acidic properties, right? To produce the carbon dioxide gas. But in solvent Y, it cannot show the acidic properties. Okay, so here another 4 marks. So this question should be 10 marks. Should be 10 marks. Okay, now we look into the section C. Solution X is added to the solution Y to form a barium sulfate. So barium sulfate. State the name of the reaction and then the name for the solution X and solution Y. After that, write the ionic equation for the reaction. So for this, okay, first we need to mention the name of the reaction. So barium sulfate is an insoluble salt. So to prepare the insoluble salt, the reaction is precipitation reaction or double decomposition reaction. Okay. So after that, you need to mention the name for the solution X and Y. So here, if you want to produce the barium sulfate, okay, so if you want to produce a barium sulfate, solution X, it must contain the barium ions. So solution Y contains the sulfate ions. So solution X, suggestion, okay, you can choose barium nitrate solution or barium chloride solution, okay, for X now, for X. Okay, or any sulfate solution that is soluble, that is soluble. Okay, then for Y, okay, any sulfate ions, okay. So for example, sodium sulfate, potassium sulfate, okay, or sulfuric acid, also can be accepted, okay. But it reject the lead 2 sulfate, calcium sulfate, because these two are insoluble salt, okay. So this is Y, this is Y. Okay, then after that, write the ionic equation. So ionic equation, very simple. If you want to write the barium sulfate, so we need the barium ions and then the sulfate ions. Okay, then you produce the barium sulfate. So 4 marks here. Okay, for next question, table shows the information on action of heat on two lead salt, two types of lead salt, P and Q. So we can see for P, when you heat it and then you release the gas, then bubbles it into the lime water. So the gas A, you release the gas A, you turn the lime water chalky. So meaning that we know this is a carbon dioxide gas. Okay, then the residual R, brown solid when hot, yellow solid when cold. So we know that this is the lead 2 oxide, right? Okay, lead 2 oxide. Okay, for the salt Q, we can see when you heat it, okay, you forms the residue R, brown solid when hot, yellow solid when cold. So we know that this is the same as this now, is a lead 2 oxide. Okay, then you will produce a gas B, which is the brown gas. So brown gas, we know this is a nitrogen dioxide. Then gas C, it will rekindle the glowing splinter. So meaning that this is the oxygen, is fixed. So here, directly we know if salt P, you heat it, it produces a carbon dioxide gas, meaning that the salt P here will be lead 2 carbonate. Okay, then for the salt Q, you release two types of gases. So very simple, this is a lead 2 nitrate. Okay. So once we know this, then we can answer the question easily. So identify the residue R. So residue R will be lead 2 oxide, right? Okay. Gas A is carbon dioxide, right? Okay. Then gas B is nitrogen dioxide. Gas C will be oxygen gas. Okay. Then after that, write the chemical formula for the salt P and salt Q. So here you need to write the formula. So P is lead 2 carbonate, PbCl3. For the R will be lead 2 nitrate, PbNO3, bracket 2. Okay, so here altogether will be 6 marks. 6 marks. Okay, next question. Okay, so you are required to prepare the dry zinc sulfate salt. The chemicals supplied are zinc nitrate, dilute sulfuric acid and then sodium carbonate solution. Okay, describe a laboratory experiment to prepare the salt. So in your description, include the chemical equations that involve. So here 10 marks. So class, first we need to determine that zinc sulfate salt you want to prepare. It is a soluble salt or insoluble salt. Okay, so we know that sulfate, zinc sulfate salt, we know it is a soluble salt. Okay, if it is a soluble salt, and then it is not the sodium, potassium, and ammonium salt, right? So we can use a few methods. So we can use the metal, zinc with the sulfate. So we need the sulfuric acid. We can use the zinc sulfate. We can use the sulfuric acid. Okay, so this is a method 1. Method 2, we can use the metal oxide, zinc oxide, react with the sulfuric acid. Method 3, we can use the zinc carbonate, react with the acid. Okay, all these 3, it will produce the zinc sulfate salt. Okay, but we have to see inside here we have zinc or not. We don't have zinc metal, so method 1 cannot be used. Then zinc oxide, we also don't have zinc oxide, so we cannot use this one. Zinc carbonate, we don't have zinc carbonate here. Okay, but we can ask, are we able to produce the zinc carbonate or not? Because this is a insoluble salt, right? If we can prepare the insoluble salt here, meaning that we can do the precipitation reaction first. Why? Because here you can see zinc nitrate, you can react with sodium carbonate first. Okay, so react first, then it will produce the zinc carbonate. Okay, after it produces the zinc carbonate, then you use the zinc carbonate to react with the sulfuric acid to produce the zinc sulfate. So the whole idea, you have to get it correct first. So first we need to prepare the zinc carbonate first. Okay, so how are we going to explain? So first one, we can add the zinc nitrate solution to the sodium carbonate solution in a beaker. Okay, so these two, we mix them together first, they will react. Then after that, we filter the white precipitate or solid zinc carbonate form, right? We get the zinc carbonate already. Okay, filter it to get it. Okay, then after that, we get the zinc carbonate, and then we put we add them into the sulfuric acid in a beaker. Okay, until some zinc carbonate solid no longer dissolve, meaning that in excess already. Okay, then after that, filter the mixture. Okay, filter the mixture to remove the unreacted zinc carbonate solid. Then after that, we transfer the filtrate into a evaporating dish. Okay. After that, we heat the filtrate, that is a zinc sulfate solution, until saturated, or we heat the filtrate about 1/3 of the original volume. Then allow the solution to cool to room temperature. Then after that, we dry the crystals by pressing them between 2 filter peppers. Okay, to dry the salt crystals, right? That is the zinc sulfate. Okay, so these are the steps. So, but a lot of students, you make the mistake because you just directly react the zinc nitrate with the sulfuric acid, which is wrong. Then next one will be the chemical equation. Zinc nitrate react with the sodium carbonate to produce the zinc carbonate. This is the zinc carbonate we want. Then after that, zinc carbonate react with the sulfuric acid to produce the zinc sulfate we want. Okay, so this is the salt we want to prepare in this question. So altogether we 10 marks. 10 marks. Okay, so I hope you can learn from mistake, okay, from this exam. Okay, thank you very much.